Today we're going to be looking at the fourth lesson of our transformations unit. The do now is a former Regents question, so go ahead and try to answer that to the best of your ability. And then we'll come back and regroup. So pause the video here. You should have filled in that a reflection is a rigid motion. It preserves length and angle measure. Those are always going to be your go-tos when we're talking reflection, rotation, or translation. Those are our three types of rigid motions. Dilations would not preserve length. You could have wrote just a reflection is a rigid motion, which would definitely explain congruency. You could have also just said a reflection preserves length and angle measure. The one thing we really can't do is say size and shape. Unfortunately, on the Regents, they don't consider that enough detail. So we want to make sure we're covering our bases here because these are points that we definitely want to have. If I go on to the first exercise for today, we're going to look a little bit deeper at reflections and isosceles triangles in particular. So right now, I know this is an isosceles triangle. I know that AB is equal to AC. So remember, an isosceles triangle is a triangle with two congruent sides. The vertex of this triangle is going to be the vertex A. It's also being bisected, which we know means cut in half, by AD, the right here. The non-vertex angles are going to be known as the base angles. So in this case, my base angle is angle B, angle C. And what appears to be true is that these two angles are congruent. If a triangle has two congruent sides, it also has to have two congruent angles. So in an isosceles triangle, the base angles are always congruent. What's true about the line segments BD and CD? Well, think about this. This isosceles triangle, if this angle BAC is being cut in half bisected, these two sides are also going to be split so that BD is congruent to CD. If we were to triangle ADC over the line AD, 2 points wouldn't move though. Neither A or B would move. The reason why is because they're on the line of reflection. So these fixed points can't go anywhere if we're reflecting over AD, because with a reflection like B would snap over here onto C. But so we're going to fill in here. They are on the line of reflection. And if we reflect a triangle ADC across AD, explain why C must be on point B. They're equidistant from each other. And they're both equidistant to point D. So both B and D are equidistant from point D there. That means it's going to be the E2 equal side coming in. Since AD is the line reflection, D is the mid of BC. We saw yesterday that a line of reflection is also known as a perpendicular bisector. Which means the angle A to B, so this angle here, and ADC are going to be congruent right angles. Okay. One other thing that's very interesting about a perpendicular bisector, we'll see in exercise 2. So we know that AB that's shown has the perpendicular bisector M, and then a variety of points along the way have been marked. What is true about each of the perpendicular bisector compared to the endpoints of the line segment? So what I mean by that is I can kind of connect this first point to the endpoint B and the endpoint A. I could do it again here along this point here. We know the line's already connected there. We know that's our midpoint of the two. I could go even further. We can connect it and make that line a little bit straighter for us. But B and A to this line here. And I can go in and connect this point here as well. What I should notice about each of those pairs of lines, like every pair of colors that I use correspond to one another. And what they keep forming over and over again, look, is gonna, if these two sides are equal, it's gonna form an isosceles triangle, just like I would here for the orange ones, and even with these blues. So every point here, all these points are going to be equidistant to the endpoints because they're along the line of reflection here, this perpendicular bisector. So every point is equidistant to both endpoints. And we formed isosceles triangles. And I'm just going to shorten that. And what we really should know, the whole big major idea of this little exercise here is that a point will lie on the perpendicular bisector of a segment if and only if it is equidistant from both endpoints. Okay, on the next page, we're actually going to see how to construct some of these lines of reflections. So remember, when you're doing a perpendicular bisector, we're trying to bisect this segment. We're trying to cut it in half. So from CD, we can stretch our compass out the full length of C, but really, as long as we're more than halfway, we're okay. This construction is going to be just throughout this whole year. So we're going to make an arc from D. Now, the big, major important part from here is that after we make that arc, I cannot change the size of my compass. I'm not changing stretch at all, but I want to get an intersection above and below or on both sides. I need two intersections. Once I have those two intersections, I can draw a straight line that's going to bisect here. And I'm just going to fix my lines because I have midpoints on the first one. But I have come in here, and I'm going to give arrows to both sides. And this is our construction of a perpendicular bisector. Now, another name for that perpendicular bisector was the line of reflection. So you'll see this as a readings question, exercise number 4. Using a compass and a straight edge, construct the line of reflection which triangle RST reflects onto R prime T prime. So again, it's the same properties of a perpendicular bisector. So we can use that same construction. All of these points should be equidistant to our perpendicular bisector. So the first step we have is just to draw in a line connecting one of our points. So I'm going to connect R prime. And we could have connected S prime and S, T prime and T. Either one of them will work. I'm just going to get my line back here. So I just want a straight line connecting these two. Once I have that, I'm ready to go into my compass, the same construction that we just did. So we can start at either endpoint of R or R prime. I want to make sure at least I'm stretched out than halfway. As long as I'm more than halfway, I feel comfortable. So I'm going to make an arc on both sides. And then I'll make an arc on both sides as well. And here is our line of reflection, just connecting those points. And it is called a line of reflection in this case. So I do want to make sure I put those arrows on because lines we know go on forever. So we get those here. The last construction we're going to look at is to construct the center of rotation. So this actually did not fall on the rotation day because we needed particular bisectors to do this. We did wait on purpose. It's not we just forgot about the rotation. Instead, what we're going to do is if we know we're rotating this, we're going to connect two of those points. So first one, we can connect here. I'm going to connect using a nice new color instead of this pink. So we're going to connect A and A prime. I'm also going to connect B and B prime, just to get it out of the way. So the first thing I want to do is take the perpendicular bisector of A and A prime. So it's the same construction we've been doing. So we start with clear piece on A. And we extend as long as we're more than halfway. If we're not more than halfway, we're not going to get our intersections. And you can make a full arc. You can also just make an arc on two sides of this, but you also run the risk of making it long enough. So make sure it's up to you. If I try this route, I did from A. Now without changing the size of my compass, I'm going to go to A prime. And this is what I was talking about. I almost missed that construction here, so you can always feel free to do the full arcs if you're worried about it. But I have the intersections, and I'm going to connect those lines now, getting one perpendicular bisector. So I have the first perpendicular bisector. Now I have to do this all again from B to B prime. This color that will show. Again, over to B. I'm using different colors if you want to try to use highlighters to help you keep your ideas in check of this. Remember, I'm going more than halfway from B to B prime, and I'm doing the same other side. So we get the arcs above and below. Then I'm going to draw the line that connects those. And I'm going to straighten this out a tad. Now, the reason why I use all different colors is because we have so much going on here. It's the first time we kind of have like a little messy situation. But if we do this correctly, oops, let's not change that color. Let's leave that. If I do this correctly, when I go out here where the green, this mint, and purple met, that is my center of rotation. And usually we'll have to label it, but I'm just going to write in here that it's the center. We didn't know the perfect bisector construction when we went to learn about centers of rotations, so now it fits in perfectly for us. But perpendicular bisectors are a big construction throughout this year. They're very helpful and one of our big go-tos. Tomorrow in class, we'll practice more of these constructions. Thanks for watching. Have a great night.